So everyone is fine. So I will be speaking on factor analysis. So before going to this section, I would like to ask you some questions so that it can be betterly understand where to we need to use this factor analysis. Okay. So do you know the perception, how to look the perception in any study? How to look up the perception?
Likert scale.
So you will go for the Likert scale.
Yeah.
And so you will see that a lot of the works needs to be done on the perception, customer satisfaction, emotion, okay, social media addictions. These needs to be assessed through the some rating scale. Okay, so although your rating scale can be a 5 rating scale, 7, 10, or maybe a 3 rating scales, that uh, depend on the your study and objective. So most of the time you need to have these perceptions, and that cannot be quantified. Okay, so basically you are giving some scale where you will trying to understand the phenomena, how it will works. So this kind of the things can be asked in a different way. So if you thought of we can ask the customer satisfactions to the one question or maybe two questions. So it's very difficult. So you are trying to look with the more questions in any research. Then you will be asking, let's say 40 questions, 30 questions, and then you will try to understand the various aspects on these uh, on the perceptions. Okay, so these perception cannot be useful. These all cannot be useful. So what you are trying to do, you're trying to reduce the number of the questions, and you need to bringing out the what are the important factor which needs to tell you about the perception of any study. So this is the one aspect where you will be using this kind of the analysis. And other one is the, let's say you trying to look up the various factors in medical sciences, or maybe from the other social sciences. So these, for the factor analysis, you can have ordinal data as well as the interval data. Okay, so you can ask on this data, and then you will trying to understand. Okay, so how you will see that if it is you will have a continuous data. So let's say if it is you trying to do some genomic analysis, and you will get the so many factors which is coming out from the experiment, and you are not able to decide that which one is more important. So in that case, you trying to understand that you will be going for the some of the important factors or some of the important aspects. So that's you are trying to do with the factor analysis. So I will be telling you how you can do the factor analysis. So here you can see that this I think is visible for you. So in any research, so you must start with the research objective. Okay, so whatever the research objective you trying to prove with your research, and then after that, once you know that these are my research objectives, so let's say my research objective is 1, 2, 3, and then after that you need to find out what are the indicators, you will ask from the field or from the experiment. And that's for an example, if you will want to see the income of any people. Okay, so income of any person, then how you will ask the questions. So this is the basically you will ask the how much he's earning from the salary, how much, what are the assets is with him. And then after that, you will trying to understand these are the indicators which will tell about the income of any person. Okay, so accordingly, whatever the indicators you are trying to look up, and then after that you will talk about the measurement. So measurement means what kind of the data you will ask. Okay, so is that data would be ordinal or nominal or interval that you would be asking. Okay, so this is measurement. Then you will talk about the how, what kind of the data you will be asking from this one, and then you will go for the field work. Then after that you will see the data and then trying to look up the data and quality checks, and you will be finding that it is in a proper shape, so that you can trying to do a analysis. Then finally you will be handling for that data for the analysis purposes, and you will coming out the some of the answer for the your research objective. So whatever is your objective, that's you are trying to find out from this analysis outcomes. Okay, and then after that you will be making your some predictions, or you're trying to find out that this is the answer of your research. Okay, so that's you will be doing in any kind of the research. So here we will talk about the what are the indicators you can also you will have so many indicators are there to look up the customer satisfactions. Okay, and so these indicators can be given through the so many questions. So let's say 50 questions can tell that these are the my indicators. So in that scenario, you will be going for the some factor analysis. So I'm trying to explain you some of example of the factor analysis. So what is a factor analysis? What is the need? So if you can trying to understand from the word only, the factor analysis is basically you will be saying that these are the factors which you coming out from the your analysis or from your data. So factor analysis mostly used for the data reductions purposes. So far you aware of that principal component analysis, explanatory factor analysis, confirmatory factor analysis, and structural equation modeling. There you will trying to do a trying to uh, reduce your data. So whatever the data you will have, that you will trying to reduce. So these are the techniques is called as the data reduction. So this is basically reducing your data. So in this case, you to get a small set of variables. So you will trying to get a small set of variable, preferably uncorrelated, from a large set of variables, most of which are correlated to each other. Okay, so you will be finding the smaller number of the variables, smaller number of the questions. Out of the many questions, as we discussing that you will have 50 questions, then you will trying to come up with the 10 questions. Okay, so you would be creating the indexes with variable that measure a similar things. Okay, so you will be finding the indexes. Indexes means you will be finding the less number of the questions for a particular case, that you will trying to understand. In factor analysis used to laminate, or it's just finding out the underlying the dimensionality of a set of items, measure prospect question of a research study. Okay, so that's you will be trying to find out the all these items, measures. So in perception studies, we will be trying to say that these are the my items. So this is are the my 50 items. Okay, then some of these questions may cluster together addiction of social networking site. For an example, I will be talking on the addiction of the social networking site. It's to potentially measure the things such things as the communication, collaboration, closeness, or commitment. So this will coming out with the depression, escape, need, and these are the my this is the one of my study that did by me, that's in on social media addictions. Okay, so This will help you to understand that how to do a factor analysis, conformity factor analysis. Okay, so in this social media addictions, we will be finding out the how the addictions can be. So here we will be seeing that how the social media addictions can be find out, and this article is available for all of you. You can just have a look of this article, and we trying to use the factor analysis. So there was the many factors which will be out the uh, social media addiction, and then after that we will be linking behind these factor analysis. Okay, so then after that I will be talking one example for the social media addictions, where you will have so many questions to understand that why the addictions is going among the students. Okay, so that paper is telling about the social media addiction among the students. So we ask the many questions: how many hours you spending time, what are the habits you changed. So many questions which we ask in that paper. So this is the basically on the perception side. So we trying to understand that perception with the help of your these questions. Okay, so that these are the rating scale questions. Now we will be, I'm taking out one more example, that is based on the continuous variable, which we will be assessing in a sports study. Okay, so that is the frailty variable. Frailty variables is just trying to understand that how the patients can behaving in that case. So we will be asking so many questions. So for an example, we will be asking the speed of walk, speed of usual walk, then time to do a chair stand, arm circumferences, body mass index, then skin fold thickness, and then shoulder rotations. Like that, we will be asking that grip, knee, hip, time to do a pegboard test. Okay, so these are the so many questions asked in this study. And then after that we will see that how. So here basically whatever you will be looking up: personality, depressions, customer satisfaction, women autonomy, in these areas we will be trying to encourage this factor analysis. Okay, so basically you are trying to minimize the number of the questions, or you will be creating a one factors among these combinations. Okay, so this is you can see that how you can use this in a different areas. So the application of the factor analysis, it's identifications of the underlying factors, that is the group variable into the homogeneous set. So we will have a grouping variable into the homogeneous set. So let's say we will say that that variable is talk about the quality of your satisfactions. Okay, of quality of the product through the satisfaction. So this is the bunch of the variable which is saying that the quality of the satisfactions. Create a new variable. So you will be trying to find out the new variable and screening of the variable. So basically you are just screening the variable. Identify the groupings to all us to select one variable to represent many variables. Okay, so that's you and useful in the regression. So helps avoid the collinearity. And then after that, summary allow us to describe many variable using few factors. Okay, so this it will allow us to describe the many variables using the few factors. Then clustering of the objects. So clustering of the object help us to put objects or basically people into the categories depending on their factor scores. Okay, so this is the basically I'm trying to explain you about the what are the where you can apply this one. So what are these some of the concept you will use while while in the factor analysis? So what are these concepts? So you will be talk about the eigenvalue. So what is the eigenvalue? And I will not tell you about the mathematical things, but its eigenvalue is measure of how much of the variance of the observed variable a factor explain. Okay, so that's will tell you that how much variance is explained for a factor. So let's say for 5 questions we will have a 1 factors. For next 4 questions there is another factor. So it's telling that how much variance is explained for these factors, which the term we will be using as a eigenvalue. So if the factor of the socioeconomic status considering of 3 variables like income, education, and occupation had an eigenvalue of 2.3, it would explain that much variance as 2.3 of these 3 variables. Okay, so this is the you can do a understanding about the eigenvalue. So the factor that explain the least amount of the variance are generally discarded. Okay, so if it is you will have the less variance, that would be a discarded, and the rest would be considered for the factors. Okay, now factor loading. So another concept is the factor loading. So it's the relationship of each variable to the underlying factor. So whatever the factor is coming up, and then it is telling you a relationship to the others variables. Okay, so sometimes you need to have you need to find out what is your factor loading. That's you will be calculating here. In the next sections we will talk about the scree plot. Scree plot display the eigenvalue associated with the factors in descending order versus the number of the factors. Okay, so this you can see here the in the y-axis you will see that the eigenvalue is there. Okay, on the x-axis what are the number of the factors is there. So you will have the 1 factor, 2 factor, 5 factors. It will tell from this one. So as I told you that what is the meaning of eigenvalue. So once you will have the high variability for the eigenvalue is higher, that would be used for the as a factors. Okay, so if you will have the lower variance is explained, so that are the discarded factors. Okay, so for example here in this scree plot you can see that this is the highest variability. So this is the first factors, so this is your second factors, this is your third factors, this is your fourth factor and fifth factor. So we will consider all those factors which has the one or more than one eigenvalue. These are the important for my analysis or for my study, and rest will be discarded. As I told you that it's showing the less variability, that would be discarded. So as there are many factors, but you will consider only the which showing the higher eigenvalue. Okay, so this you will be explaining from. And another way is that from this scree plot you just deciding that how many factors you would be requiring. So you will require the 2, 4, 5 factors that you will be finding from this graph only. Okay, now rotations. So rotations is in principal component. So in principal component the first factor describe most of the variable. Okay, so what is happening that but the first factor is describing the most of the variability, and in that case you would require the rotation. So you need to rotate these variability among your data, and then again you will get the another factors. Okay, so sometimes you will require the rotation. So I will tell you where and how the rotation would be required. After choosing a number of the factors to retain, how many factors you will be retaining, we want to spread the variability more evenly among the factors. Okay, so to do this, we rotate the factors. Okay, so what is the happening in that? Choosing the number of the factor to retain, we want to spread the variability. So we want to spread the variability among the all the factors. Okay, so for that you need rotations. So there is a one options you will be finding in the SPSS that rotations would be required, so that you can use. So redefine factors such as the loading on the various factors tends to be a very high or low, very low. Okay, so you need to redefine your factors such as the through the loadings, and it makes sharper distinction in the meaning of the factors. Okay, so it will give you the more accurate factors while you will be using the rotations. So what kind of the rotations techniques you can use, means what kind of the formula you can use. So commonly used rotation is the varimax, and there would be some more uh, method would be available, but you can just decide according to your need. Okay, so I again I'm coming on the priority examples, so which we discuss about the what are the variable is there. So in that example, let's say I got all these are the my variables. So on the first column you can see that these are the my variables. So arm circumference, skin fold, fast walk, grip, like that. Okay, so these are the my variables, and here you can see that these are the my factors: the size, speed, hand strength, leg strength. So here you can see that this is these are the your values. Okay, so here you can see in this data, but it is not, you can see that it is the 0.97, 0.71, 0.89, and that is explained by the three variables in this one. So speed can be explained by the 2, and hand strength can be seen through the 0.93 or 0.57, and leg strength by the 0.72 and 0.68. Okay, so these are the combination which we will be getting. So basically what is I'm trying to explain you the social. I'm taking another example. So for an example, socioeconomic status. So socioeconomic status can be understood through the income, education, occupation, house value, number of the public parks in a neighborhood, number of the violent crime per years in a neighborhood. Okay, so these are the you can see that this can be understood through the two factors, so factor 1 and factor 2. Now you can see that how this income, education, occupation, household, where it will go. So by these value you can see that the income, education, and the occupation. So this is the 0.65, 0.59, 0.48, and 0.48. Okay, so this is the making of one factors, and if you will see that corresponding to this factor 2, so 0.60, 0.57, and 0.55, it will creating the another factor. So this is the factor 2. So you need to understand that these are the two factors coming out of these 7 questions. Okay, so the out of these questions, these two factors is coming up. So that's you trying to read, trying to make it. Okay, so how many factors you will be creating through the whatever you ask in the field or an experiment. This is basically idea about the your study. Now next question is that what name is required for factor 1 and factor 2? Can you tell me what name is required here? So if you will see that we are asking the income, education, and occupations, and in the other sides, you will be asking the factor 2 based on the number of public parks, house value, and neighbor of violent crime per year. Okay, so you need to give the names to these two factors. So as you are the researchers, then you need to give the names to these factors. Okay, so you need to give the names to these factors, which will telling there what is the basically a requirement. Okay,
Sir, actually, what are these values like 0.65, 0.59?
these are your eigenvalue. I will be telling that basically I'm trying to say you, so that's we getting the two factors. Okay, so those where in the corresponding to each questions, whatever the highest value is coming up. Okay, so whatever the highest value is coming up, that is linking to the one factor. So for an example, these three value are higher in the factor 1, so this is the linking to the factor 2. But here in these three value is higher in the factor 2. So these eigenvalues is important for the factor 2. So similarly, you can create factor 1, 2, 3, and so on. You can create the many factors. Okay, so now as you are the researchers, then you can put the name of these factors. So it can be anything which can talk about the combination of these all three variables. Okay, so that's you need to do. So some of you are saying that what are the name is required. Okay, so here you can give the it's basically socio economic, that is the giving for the factor 1, and if it is you household value, that can go for the factor 2. So these kind of the nomenclature you can give in this case. So factor 1 and factor 2, you can decide, because you are the researchers, you gone through this so many literatures, and then accordingly you can find out that these are the suitable names for these factors. Okay, now so the variable with the strongest associations to the underlying latent variable, that is the factor 1, is income, with the factor loading of 0.65. Okay, this we saw in the last table. In this data, you will see that this is the, for the income it is 65. The other variable is associated with the factor 1 are the education on occupation. So you can give the individual socio-economic status for the factor 1, and for 2 you can give the neighborhood socio-economic status. Okay, so this way you can give the namings to these two factors. Okay, so this you can give for the one factors, and this can be go for the your next factors. All right, so this way you can give the naming to the your factors. All right, similarly you can find out that what are the better way to give the name of the your factors. Ultimately you just find out the, so now you can see that what is your factor. So it is the individual social economic, and this is the neighborhood socio-economic status. Okay, so these are the two names you can provide for the factor 1 and factor 2. All right, now we will be seeing that how you can do, or which software you feels that it is more comfortable. So running this factor analysis through the Stata and SPSS or R or SES, you can do that also. So here I will be showing you this, or the how
Sir,
factor analysis can.
So you were saying about rotation. So like in that factor, like in that example, when we will apply that rotation?
Yeah, I will, once I will be, it's coming up, coming for you. So
Okay, sir.
just bear for some more time, and then we will be discussing. Okay. So this you can perform with the Stata as well as SPSS or in R as well. So the command to run the factor analysis is Stata, that you can use the factor and whatever the variable is there, and you can write, you will be using the principal component factor analysis. Okay. So after this, you can use rotations if you require. Otherwise, you can just find out. So you can see here as well. So this is the your eigenvalue, and uh, these are the your factors. So factor 1, 2, 3, and which are the factor is important. So this is the created the factor important. So just you need to write the name of the your variables and then write PCF. It will give you the output of the Stata. So I will not go much in that, but even you can just see that the factors 1 and factor 2 is very important, and it showing that it's a 1.4 value and 1.4. And in that case, if you want to use the rotations, so rotations will give you the more better idea. If it is these variable tree is spread in spread more than 2 variables. Okay, in that case you can go for the rotation. So I will also demonstrate you how you can do the rotations as well. So another options could be to create the indexes out of each cluster or variables. For example, honor and competitions define one factors. These two can be aggregated to create a new variables to measure the market oriented attitudes. The ideals, equality, and the respawn can be aggregated to the new variable, that is the egalitarian attitude. So that you can just see that this could be my one factors. Okay, and this is the your market oriented attitude. So this you can give, and this can be, these two new variable can be created for the general market, general egalitarian. So by these two variables, or maybe you will be having the 3 variables. So choosing the number of the factors, so to select how many factors to use, consider the eigenvalues from the principal component analysis method. So how to decide what value you need to take up? So in the last slides, in this uh, uh, previous slides, you seen that the scree plot is saying that. Okay, so I explain you in a scree plot, and this is nothing but it's a replica of this scree plot. So if you need to see that the number of the eigenvalue greater than 1, that is the important for the your factor, deciding the your factor. Or you can go for the second way is the scree plots. You can go for the scree plot, then percent variance explained, so how much variance is explained, and comprehensibility. So this you can decide. Again, I'm coming back to the parity example. So here we see that um, the components are there. So this is the first component, 2, 3, 4, and 13 component are there. And then eigenvalue differences and proportion are there, and cumulatives are there. So here you can see that the first component, 2, 3, and 4. So how many value which is coming more than 1? There are the 4 factors. So 4 component. So that you can see in scree plot as well. So both the way you can decide about your factors. So this is the first factor, this is your second factor, and third and fourth, which has the more than 1 eigenvalue. So if you will have more than 1 eigenvalue, that you can decide here. Okay, so now what is happening? There are the 5 factors and unrelated. So just I run the factor analysis and getting these are the my loadings. Okay, so this for the one variable arm circumferences. So this is the you can see the variable column. So first column, and the first question is that arm circumferences. So you can see that the loading value is 0.59 for the one factor, and it is also spreading in the second factor 0.67. Okay, so usually what is happening that it's saying that the arm circumference is important for the factor 1 as well as factor 2. Similarly, the skin fold is important for factor 1 and factor 2. So this is the basically problem of the rotations. So here you need to use the rotation. So some of you ask about the how or where to use uh, this eigenvalue. Okay, so these are the loadings are here. So these loadings needs to be adjusted. Okay, so this is the unrelated unrotated data. So now you can use the rotation techniques. Okay, so that it will the one variable links to the only one factor. It cannot links to the two factors. So that's you need to create with the rotations. Okay.
Sir, in the previous slide, we got 4 factors now, but here you have considered 5 factors.
Okay, so here you got the 4 factors, but I'm telling you, these are my different data.
Achha, okay, sir.
So here I'm saying that how to just link up with these two values. So here you just see that eigenvalue, which is more than 1. In the data as well, you can find out, or you can just find out from the graphs only. Now we will coming back to the question which we discussed in the second slide. That is the here. So this is the problem of the rotation. Okay, so here you need to use the rotation. So how you can use, what is the meaning of the rotation? So one variable linking to the two factors, so it cannot be happen. Okay, so it can link to only one variable, so that can be done with the rotations. So now I run the rotation. Okay, so I gone through the analyze, then factor analysis, and then click on the rotations, and then it's giving you this output. So now you can see that the for this one factor for factor 1, the loading value is this is links to the one factors. Here this is also giving to the one factor 0.9, 0.4. So no overlapping is here. So now you can see the across the all 5 factors, no, all values are very less. Okay, so across this one also you can see that all values are less. Across this, all values are less.
Or like I'm not understanding what is like this factor. Like it is unknown for now, but then like you are saying like we have to group then and then we have to name it. So like actually we are finding some factors, or exactly
Yeah.
what we meant by like factor 1, factor 2.
So it's basically you will have 50 questions. Okay, so 50 questions. Now we can create some factors. So based on the 50 factors, you want to create the 5 important factors, maybe 10 or 6, like that. Okay, so once these factor can be decided based on these loading value. So this is the loading value. So for example 0.91. So it's telling that these 1, 2, the bold value. So this is the fast walk. This is the PAG BRD value, and this is the usual walk and chair stand. This will telling that it is creating the one factors. Okay, so these question linking to the one factors. Rest another question will links to the factor 2. So out of the 50 questions, you need to decide that which question is important for the factor 1, which questions are important for the factor 2. That's you are doing here.
Okay, sir. And can also you explain like the interpretation of these numbers, like negative number, positive number? What does that imply?
Yeah, that's I will be doing. So we will be discussing all these.
Can you please give one example in this? Yeah, it is there.
So I'm telling you the example only. So just you can see this or this. here as well.
Right. Especially from the data set.
Yeah, I will be I will be telling you through the SPSS as well, or through this data as well. Okay. So this is the correlation matrix. You can see that this correlation matrix between these variables. So this you can also understand that what are the correlations between these two variables. And this is the principal component analysis, and where it will tell you that the factors, eigenvalue, and the variability explained, and the cumulative variance. Okay, so this you can see. So now negative value in the loading is the reverse scale. So if it is any negative value is coming in your loading, so it is called as your reverse scale. And variance explained. So whatever the variance explained in your data, that should be greater than or equals to 10%. So for example, in the last one, here you can see that this is the variance explained. So whatever that more than 10% is coming up, that is your considerable value. Okay, so this is the variance. So what is the basically what point you need to consider the variance explained? So if it is more than 10 or equals to, that is your variance explained. And this is the commonalities. Okay, so commonalities of the this one. So this is the less than 0.5, then delete the variables. Okay, so if it is this is coming up, then these are the commonalities. Okay, so this commonalities is coming to be less than 0.05, then you can delete that variance from your analysis. Okay, so if you will see that this BP, LR, L, SAT, or all this will have the value more than 0.5. So that you can consider. If it is any one is not coming, that you can say that you can refer these values. So you can note down these values, which you can use for the interpretation purposes. Now we will again be taking the another example. So rotations. So once you obtain the minimum number of the factors, you have to interpret them. Interpreting original solution is difficult. Rotations add interpretations. So you looking for the simple structures, you can go for the unrotated matrix, and this is your rotated matrix. So what is the happening that you will see that this A variable is linking to the both the way. And here it is just saying that it is linking to the one way. So after rotations, the variance accounted for by a factor is spread out. So it's spread out among the each factors. So first factor no longer account for the maximum variability possible. Other get more variances. So total variance accounted for the same is required by the type of the rotations. So you can use the orthogonal or factor uncorrelated, or oblique you can go for the factor correlated. So in orthogonal rotations, you can go for the Varimax, Quantimax, and EQmax. So most of the time we will be using the Varimax rotations. Okay, so this is the theoretical aspect which you can understand about the factor analysis. Now I will tell you through the SPSS how you can do that. So now you can open this data, or you can see this data, run, talk. So we are having the run, talk, case, write, eat, sleep, and mumble, read, fight, bleach, argue, jump, cry, and laugh, and shout. Okay, so now we will see that how you can use the factor analysis. So I'm going for the dimension reduction. So this is the basically I want to reduce the number of variables from whatever the variable I used in my research. Now you want to reduce all those variables. So you can go for the analyze, then dimension reduction, and then factor. Okay. So these are the my all variables. Okay. So I will take all these variables to the my variable. Okay. Then you will see that here is the descriptive statistics is there. So you can find out the coefficients, KMO and Butler test for the sparsity. You can go for a principal component method. So unrotated, you can go for the scree plot based on the eigenvalue. So eigenvalue greater than, so this you can decide. So what are the factors you will considering? So that you can consider from here, or you want to go for the fixed number of the factor to extract. So let's say you don't want to go for the more than 4 factors. So you can fix it over here. Okay. And otherwise you will see that whatever the value, the eigenvalue is coming more than 1, that would be your factors. Okay. This way you can go. And a scree plot, if you want the scree plot, so you can select and then you can go ahead. Rotations, so you can go for the method of rotations. So here is still we will go for the none, then you will go for the varimax and quantimax, eqmax, and promax, and the direct oblique. And these are the loading plot if you want, so that you can go for the loading plot. And you can continue, and this one. So you can go for the score. So you want to save these scores, so that you can do. Okay, so this much you can do here in the factor analysis. So by default, first we will see that how you can do. Okay, so I will be clicking on OK, and this is your output. So let's say out of these variables, so out of these variable, is any variable needs to be go for discarded, or should I delete one? So I can see the value of the commonalities. Okay, so if it is any value is coming less than 0.5, that can be deleted. Okay, so from this table, all variable are useful or not, that you can decide. So here all value is coming more than 5. So here you can keep all the variables. So first table is showing this one. Then after that, you will see that total variance explained. So here the component 1, 2, 3. So it's saying that it's showing you 1, 2, 3 factors. So this is the variance explained here, the 58, 12, and 9.3. Okay. And these are the 3 factors which is coming out from this data. Now component matrix. So this component matrix is with respect to each question. So component matrix means basically these are your loadings based on the principal component analysis. And you will see that run is responsible for 1 factors, and there is no other things is there. But in the talk, you can see that it is 0.55 and 0.67. So it is the talk is responsible for the factors 1 and 3. So that is not a good idea coming out from this statistical output. Now I have to think of the other options. Let's see for next variable. So this case is fine. 0.8 is responsible for only 1, but right is responsible for these 2 variables. So 1 and 2. Eat is So you can see each and variable. So now after that, you can decide that should we go for the rotations or not, that you can decide. So this is your initial output. Now I will be going for some more things. Dimension reduction, then factor. Then I will select here the univariate descriptive statistics and the KMO that you can select, and then continue. Then extractions, you can go for the screen plot. You can decide that I will be going for eigenvalue 1. Rotations, we will do rotation in the next case. Okay, so now I'm clicking on OK. So this is your descriptive statistics. So this is the main of your variable, and then standard deviations, then correlation matrix. These are the communities where you need to decide that any variable needs to be deleted or not. Then again, these 3 factors is coming up, and you can see from this scree plot. Okay, so you can see that the eigenvalue which is more than 1 is the only 3. So you can consider only the 3 factors. And this is the component matrix. So component matrix having some problem in that. So because these loadings are responsible for the 2 factors, so I need to use the rotation. So again, I will go back on the factor analysis and going for the varimax. Okay. And then after that, I'm saying this is the go for the rotations to correct the loadings. So now this is your output factor analysis. Then you can see here, is there any variable needs to be deleted? Then again, it will showing you 3 factors, and the total variance, maximum variance is explained by only these 3 factors. And from the scree plot, you can decide that how many factors you are deciding here. Now you can see this component matrix. Okay, so this was your original component matrix. Now this is your rotated one. So in this rotated one, you will see that run is responsible for factor 1, and other is very less value. Talk is responsible for 1, but other are less. Similarly, kiss are responsible for 0.73. Then write is responsible for factor 2, and eat is responsible for the factor 1. This sleep is responsible for factor 2. So similarly, now your rotations is workable. So this is your component transformation matrix, is that this is the factor 1, 2, 3, and this is your component matrix which is extracted from this data. And this is your component plot in rotated space. So this is, you can see that this is your component 1, component 3, and component 2. Okay. So this you can see. So this is the basically this is the overall your output of the factor analysis. Now you can do the interpolations. Okay. So how many factor is coming out? So that you can show that you can put this output into your thesis or in your papers, wherever you want. And you also need to tell about the scree plot. So this is basically the interpretations.